Python programming language has multiple data types and data structures that you can use to store and manipulate data efficiently. In this video, we will discuss the Python data type float. Hey everyone, welcome back. In this video, we're going to talk about one of the most important Python data types for working with numbers, the float. If you've ever dealt with decimals, currency, scientific measurements, or precise calculations, this is the data type you've been using. Let's explore what makes float so useful and how to work with it like a pro. In Python, a float, short for floating point number, represents any real number that includes a decimal point. So numbers like 3.14, minus 0.001, and even 5.0 are all considered floats. Even if it ends in 0.0, like 10.0, it's still a float. Floats are stored in your computer using a format called IEEE 754, which is a standard way to represent real numbers in binary. But because binary doesn't always perfectly represent decimal fractions, you might occasionally see something known as rounding errors. For example, here we add 0.1 plus 0.2, and note instead of getting exactly 0.3, we have a little bit of a rounding error way over to the right. Yeah, that's weird, but it's totally normal in floating point math. We'll talk more about handling that in a bit. You'll use float anytime you need precision with decimals. That could include calculating measurements, dealing with currency, working with percentages, doing scientific or statistical computing. Basically, if it's not a whole number, use a float. Here are some things to keep in mind when working with floats in Python. The decimal point is what makes it a float. 5 is an int. 5 decimal point 0 is a float. You can use the float function to convert strings or ints into floats. Floats support all the usual math operations, such as addition, subtraction, multiplication, regular division, and powers. Use the round function to control how many decimal places that you see. And be cautious with comparisons. Because of rounding errors, equal may not always behave how you expect. Let's try out some quick examples. Float values are useful for basic math. In this example, we see a formula for calculating the total price, including sales tax, applied to the float variables of price and tax. You can use the float function to convert other types to float. Note that an integer converted to a float will retain its value but add the decimal point followed by 0. A string will simply become a float. But note that not all strings can become a float, only string representations of float-like values. But remember to use comparison of floats with caution. In this example, the sum of the two floats introduced some round-off error, so A is not actually equal in value to 0.3. Fortunately, the Python math class includes a nice function to help when comparing floats. Here we use the math isClose function to compare the two values and avoid the float comparison trap. The isClose method has a default tolerance to determine if the two numbers are close, but you can add an argument to specify if you want more or less precision. So that's a quick tour of Python's float type. It's perfect for handling real-world numbers, but it does come with a few quirks, especially when it comes to precision. Now that you know what to look out for, you'll be able to use floats with confidence in your projects. Thanks for watching. If you found this helpful, give it a like, subscribe, and let us know in the comments what Python topic we should cover next. Until next time, happy coding.